A man lives on an island 4 kilometers offshore across a channel which has a 3 km/h current when the tide is running. With the tide running, he rows from the mainland dock toward the island, keeping his boat aimed directly north. The island dock is due north of the mainland dock. He rows his boat at a speed of 4 km/h relative to the water. Where will he land? Alright, so essentially with this question, all we're really going to be using is a bit of trigonometry. And we can essentially relate his speed going north and east, which we'll find, or which rather is given to us, and we can relate that to the distance using similar triangles. So let's just write out the vector here. So as we can see, he's going to be going 4 km/h north. And then the current is going to be taking him 3 km/h east. Okay? So essentially we'll have this resultant vector, as we can imagine, and he's going to be moving in a diagonal line. But we actually don't even need to find the resultant vector. It isn't going to be used in the question at all. Well, what we need to really realize is that this triangle right here can be related to our situation here. So as we can see, we have a distance of 4 kilometers. And if we know that we have this triangle here, we can relate this to the distance. And so, in fact, if we find this angle right here, we can also use this to make our triangle for the distance. But we don't even need to do that, because this right here, 4 kilometers, is the same. It's obviously just kilometers instead of km/h, but since they can be related, we know that for every 4 kilometers here, traveling at this resultant vector, he's going to move a certain amount of kilometers to the right as well, right? It's all related. And so, in fact, we can actually say that he's going to end up 3 kilometers downstream. Now, let's prove that with this angle here, though. So this angle right here is going to be equal to tan theta will be equal to, and then we have opposite over adjacent, which is 3/4. So now we want to solve for theta, right? So let's take the inverse tan of both sides here. So theta is going to be equal to tan inverse of 3/4. And that's going to give us 37 degrees. Okay? So now we have that this is going to be equal to 37 degrees. Now let's plug in and make our triangle here. So we know that this is 4 kilometers distance. And then we have some side length here and this exact same triangle, right? Well, if we know this angle is going to be 37 degrees, then all we really need to do is say tan 37 is equal to opposite over adjacent, which in this case opposite is the distance and adjacent is the 4 kilometers. Then we multiply the 4 up, so 4 times tan 37 equals d. And what do we get? Well, we get, of course, that d is equal to 3, okay? So we just have to realize that our speed is related to our distance here, and that when we know this distance, and we know what our horizontal velocity is, we know that this can be related to our distance, okay? So that's all for this one. I hope that makes sense. Thank you. Bye.